Section 13.1 is right triangle trigonometry. We are starting out with example 2 or problem number 2, finding the sine, cosine, and tangent for theta. Here is theta, here's the angle that we are using. Go through and label all three of your sides first. 15 is across from the right angle, so 15 is the hypotenuse. Across from theta we have 12. That is the opposite side, and 9 is next to theta. It helps make up the angle. For theta, that is the adjacent side. So sine of, you need of an angle. That angle is theta. Sine is opposite over hypotenuse. 12 is the opposite. 15 is the hypotenuse. You can reduce 12 over 15, or it's fine with me if you leave it. Cosine of theta. SOHCAHTOA, so cosine is the adjacent side, 9, over the hypotenuse, 15. And the third one is tangent of theta, that's TOA. So tangent is the opposite side, opposite theta is 12, divided by the adjacent side, 9 is adjacent. Number 10, find the values for, this one asks you for the values of all 6 of the trig functions for theta. And last time they labeled all 3 of the sides for us. We had the lengths of all 3 sides. For number 10, they only gave us 2 of the sides. I feel like I might have written it down wrong. But in any case, for this example, 3 and 5 are the legs. We need to find the remaining side before we can go through and find the 6 trig functions. Since this is a right triangle, we can use Pythagorean theorem. A squared plus b squared equals c squared, c being the hypotenuse that we're looking for. So if I take the square root of both sides, then I get c is the square root of 34. There are no perfect squares that go into 34. There's no way that I can reduce it, and we're going to leave exact answers, not decimals. So the hypotenuse is square root of 34. So again, go to your angle. Let's go through and mark all 3 of the sides, label the sides. 34 is the hypotenuse. Across from theta is the opposite side, that's 5. 3 is next to theta, that is the adjacent side. So our 6 trig functions, sine, cosine, and tangent. And then I'm going to list the reciprocal functions next to them. It'll make it a little bit easier when I go through and do it. The reciprocal of sine is cosecant theta. The reciprocal of cosine is secant of theta, and the reciprocal of cotangent is cotangent. Sine is opposite over hypotenuse. We don't want to leave our answers like that, so we're going to rationalize by multiplying top and bottom by radical 34. Ran out of room. Cosine is the adjacent, 3 over the hypotenuse, radical 34. I'm going to rationalize again, and because I'm out of room, I'm going to skip writing this step. 3 radical 3, or 34, over 34. And tangent is opposite over adjacent. So when you do your reciprocals, you can go through and look at your flip sheet and look up that cosecant is the hypotenuse divided by the opposite, or if you know that they're reciprocals, you can flip them. So if I flip the sine function, if I take the reciprocal of the sine function, do it before you rationalized, radical 34 over 5. Secant is the reciprocal of cosine, so the reciprocal is radical 34 over 3. Cotangent is the reciprocal of tangent, 3 over 5. The final example for today is a story problem. There is an airplane. It is traveling at, I believe, 235 feet per second going this way, and it's supposed to drop supplies or something over a target. It is 2,000 feet in elevation, so it is 2,000 feet above the target, and it says that if you're in the plane and you look down to the target, that is the angle of depression right there, is 14 degrees. So this has a part A and a part B. Part A wants you to know how far away horizontally you are from the target. Okay, so horizontal distance from the plane to the target is the side labeled X up there. So that's what we're going to find first. Start with identifying the angle you have. That's my angle 14 right here, and labeling the two sides. I don't know anything about the hypotenuse, and they don't ask me about the hypotenuse, so I don't want to use that side. I have the 2,000, so if I'm using angle 14, 2,000 is opposite 14, so I'm going to label that. And then I want to find X. X is next to that angle, touching that angle, so that is the adjacent side. So remember that we have trig function of an angle. Our angle is 14 degrees is equal to a ratio of two sides. So if you look now, we have the adjacent side and the opposite side, so you look in your notes and figure out which trig function to use based on those two. The function that relates the adjacent and the opposite side is tangent, so we can fill in tangent now. And tangent, the ratio, is opposite over adjacent. So 2,000 will go on top of the ratio in the numerator and X in the denominator. And then we solve for X. So you can either turn this into a proportion and cross multiply, or you can multiply both sides by X here. Those cancel. And then divide by tangent of 14 degrees. So those cancel, and we get X. I think that it asks you to round to the nearest foot. So X is about 8,022 feet. If you didn't get that answer, make sure that your calculator is in degree mode, because our angle is given to us in degrees. So that is part A. The plane is 8,022 feet away from the target, a horizontal distance. Part B says, I think part B says that it's supposed to drop these supplies when it is 500 feet away. So this right here, it's going to drop the supplies. This is 500 feet. And they want to know how long should the pilot wait. So what we really need to find is how long is it going to take the plane to go that far. And they told us that it goes 235 feet per second. So to figure out how far it's going to go, this whole distance is 8,022 feet. And I don't want it to go that last 500 because I want to drop it before it gets that last 500. So 8,022 minus 500 is 7,522 feet. So how long will it take the airplane to go 7,522 feet if it is traveling at a speed of 235 feet per second? To find that, we would divide. It would take the airplane 32 seconds. So the pilot from this point should drop the supplies in 32 seconds. So here's part A, and here is part B.